Okay, good morning, good afternoon, whatever it is for you out there. We got 9-5 here today, 9-5 tangents. Let's just act like this is a normal day, even though it's not. Let's try to move on here with our chapter. Okay, so 9-5 tangents, here we go. Oh, turn this off. Okay, so a tangent, we've seen the word tangent before when we did sine, cosine, and tangent, but it's totally different now. Okay, a tangent line is a line that touches the circle at exactly one point. Okay, so I give a little picture here for you. So if I have this circle here, this line L is a tangent line. Okay, because what it does is it touches the circle at this one point, and then it keeps going. So a tangent line never goes inside the circle, it just touches it and keeps going by. Okay, so this line here that they gave us here, remember that's a radius, going from the center to the edge. A radius and a tangent line always make a right angle together. Okay, and it says that right here in the words, the line is tangent to a circle if and only it is perpendicular. Okay, remember what perpendicular means? It means a right angle. And to give that little symbol right down here, you guys might remember, an upside down T also means perpendicular. Okay, so what we're going to do on this next slide is, they're going to give us some information, and we're going to try to determine if it actually is a tangent line, if it only touches it at one point. Okay, so here we go. Okay, here we go. So this circle right here, they gave us this weird little design of a circle with a triangle kind of on top of it. What they want us to do is they want to use that information. It says KL is a radius. Determine whether LN is tangent to the circle K. Justify your answer. So the way we would decide this is, what they're really asking is, if I extended this line out a little bit farther, would it go inside the circle a little bit and hit it twice then? Or is it just going to hit it once and keep going? And the way we decide that is, some of you guys might be able to figure this out, but if this was a right angle, like it's supposed to be, when a radius and a tangent meet, it's supposed to make a right angle. If that's a right angle, then that means if I used the Pythagorean theorem here, with all three sides, if I put all three of those numbers in there, and if it works out, then that means it is a tangent line. If I put the numbers in and they don't equal, then it's not a tangent line. So remember, the Pythagorean theorem is a squared plus b squared equals c squared. Okay, the c, if you guys remember, that's the important letter. The c is always opposite the right angle. So that's going to be my c. The a and the b, doesn't matter which one's which. I'm going to go smaller to larger here. So that'll make it be just like this. 20 squared plus 21 squared equals 29 squared. Okay, so 20 squared is 400. 21 squared is 441. And 29 squared is 841. So I just add these numbers together, which is also going to be 841. So now in this one here, I got 841 equals 841. So since those numbers are exactly the same size, now I'm going to put a little check mark saying, yes, this line here, this line LM, that is a tangent line. So if I were to extend this line out, it's not going to go inside the circle, it's just going to hit there at that one point and then keep going. So that makes it a tangent line. So if this ends up not working, if it said like 841 equals 822, then I'd say, nope, they're not tangent, it's not tangent, so it would barely either not touch a circle, or it would either go in the circle a little bit and come back out later. Okay, so if it is tangent, the Pythagorean theorem is going to work just like it did there. And they put it really wordy in this stuff down here, but this is what you want to do. Use the Pythagorean theorem. If it works, that means that's a right angle, which makes it a tangent line. Okay, next one, we're going to do the exact same way. It says, is this a tangent line? YZ. So the way we decide is we put those numbers in the Pythagorean theorem. So remember, my right angle should be right there. So opposite the right angle would be C. So it would be 14 squared plus 16 squared equals 21 squared. Okay, 14 squared, that is 196. 16 squared is 256. And 21 squared is 441. Okay, if you can do that math in your head or just do it by looking at it, that's not going to get you 441. I can tell us by looking, 6 plus 6, that's 12. It's not going to end up with a 1 there at the end. So I can tell us right here Those two are not going to be equal to each other if I add 196 and 256. So the answer is going to be B. That is not a tangent line because when I add these two numbers, I do not get 441. Okay, so that's the first type of question you'll have in this lesson. We're trying to decide are they tangent or not. Now what I'm going to do from here is I'm going to give you a picture very similar to this, but it's only going to give us two numbers and maybe like an x right there. Or maybe two numbers here and an x right here. And we're going to try to solve for x. But really the same type of idea. Okay, so here we go. Find the value of x. I'm just going to draw a couple for you here. So here we go. First one's going to look like this. Let's go. We got a radius right there. I got my tangent line coming out. I'm going to connect them together with a line coming from the center there. So my right angle, I'll put that in a second actually, I'll put right angle in a second. Let's say this is 8 there, 15 there. Then I'm trying to figure out this whole distance from the center to that point right there. That whole side there is my x. Okay, so where a radius and a tangent line meet, that is supposed to be the right angle. Okay, so they're not going to always draw the right angle for you. Usually they're going to leave it without it. But if that's a right angle, then I'm going to use the Pythagorean theorem. Because usually for Pythagorean theorem, you use it whenever you have two sides given to you, and you're trying to find the third of a right triangle. Okay, so that's what I'm doing right here. I've got two sides given, trying to find the third side. So just like in the last questions, opposite the right angle, that's my C. The other two are my A and my B. So I do 8 squared plus 15 squared equals x squared. Okay, solve this down. 8 squared is 64. 15 squared is 225 equals x squared. So since they're on the same side of the equal sign, I'm going to add them together to make that 289 equals x squared. And the final step to get rid of that square, we do the square root. So square root of both sides, that's going to give me 17 for x. Okay, so that's a normal question. You'll see something like that. But you have to see, if you have a right triangle, now they're not going to give you the right angle, but you need to understand that's a right triangle. If they give you two sides, to find that third, we do Pythagorean theorem. Okay, I'm going to give you as another one now. Let's change the color up here. I'm going to do blue. Okay, next one, a little bit different. Say we got a picture like this. It's going to look about the same to start. I'm going to give you 58. There to there, that whole distance. And then 42 down there. And the next over there. Okay, so we got our tangent line here. As it comes and hits a circle at one point. I have my radius right there. Now this is a radius too, but since it keeps going, I'm not considering that a radius because it keeps going by. But this here's a radius, so where those meet, that's going to make a right angle. So again, I know it's a little different, but if I have two sides of a right triangle, to find that third, I use Pythagorean theorem again. Okay, so the difference here, if you look, see my right angle's here, opposite the right angle, my C is going to be a number this time. Now we've done that multiple times before, but just so we have one to think about for this lesson, C is going to be 58 here. The x and the 42, I'll call the x my A, and 42 my B. So I got x squared plus 42 squared equals 58 squared. Big numbers, I gotta grab a calculator real quick. Okay, 42 squared is 1764. X squared plus 1764 equals, okay, then 58 squared, 3,364. Okay, so big numbers. Next step, I need to get this over there to there. So since it's plus, I need to subtract it. So minus 1764 on both sides. Okay, so x squared equals 3364 minus 1764 is 1600. And then final step, get rid of that square, by taking the square roots. And square root of 1600 is 40. So x equals 40. Okay, so not super difficult, hopefully, but still a lot of Pythagorean theorem here on these first few examples. I got one more for you. So one more kind of like this. Here we go. Do that. Okay, this one's a little bit tougher looking. So I'm going to put 6 right there, 15 there, and x right there. Okay, so the idea on this one, first thing you have to understand is this x, the way I put it here in my picture, it's not this whole side, it's from there to there. So I'm trying to get this little distance right here at the end. That's my final answer. So a little bit weird. Different ways to explain it here as far as how to start. Some of you guys might be able to see something before we get going. But instead of trying to find x, what I'm going to do is I'm going to try to find this full side here first. And I'm going to call that y. Okay, so I'll use a different color here. So y is going to be from there all the way to there. So this full distance, I'm going to find that first. And then some of you guys might be able to figure out what to do from there. But if I figure out y first, then I can get x pretty easily. Okay, but I got 6, 15, and y. Those are my 3 sides of my triangle. So I'll do Pythagorean theorem again. The y would have to be my c, because it's opposite the right angle. 6 and 15 are the other two. So I got 6 squared plus 15 squared equals y squared. Okay, so 6 squared is 36. 15 squared is 225 equals y squared. Okay, and then if we add those together, 36 and 225, what's that? 261 equals y squared. Okay, and last step is get rid of that square by doing the square root. So square root of 261, oops, wrong button here, there we go, is 16.2. That's what we're going to do here if we get a decimal on this lesson, this 9-5 lesson. We're just going to round to the nearest tenth, probably the easiest way to do it. Okay, so 16.2, that's my y. Now it's not the answer. What they want is the value of x. Now some of you guys might be able to see what to do from here, but obviously I can't really talk to you. So the way we're going to do it, if this is a radius, remember in a circle, every radius is the same length. Every radius is the same length. So if this radius here is 6, then this radius is also 6. So I put that in there, that's 6. I just figured out this is 16.2. Okay, see what to do from here? 16.2 is the whole thing. That part is 6. So to find x, all I have to do is subtract. So do 16.2 minus 6. That's 10.2. So x is going to be 10.2 for our final answer. Okay, kind of a little more difficult one. But if you see that little x being outside there, what they're trying to tell you is use your radius that's already given to you to find the other piece of your circle. I'm sorry, of your line. Okay, so there's a little bit of Pythagorean theorem questions. Next type of question you're going to see is something like this. Kind of like a snow cone on a side or something. But this thing can be rotated wherever. What's going on here is we have 2 tangent lines. So they both start at the same point outside. This tangent line hits A, and this tangent line hits a C. What this little theorem says is that those are both tangent, and they come from the same point, then the distance from B to A is the same as the distance from B to C. I'll put little dashes on it. Those 2 distances are always the same, because if you have the same point where they're starting, if a circle is a perfect circle, the distance from there to there has to be the same as the distance from there to there. Okay, so what they're going to do on these next couple examples is they're going to give us some information here, and we just have to understand that they are the same length. Okay, so if you have two tangent lines coming off the same point, they're the same length. Okay, so here we go, so an example. Okay, here we go. So this first example here says AC and BC are tangent to the circle. So we have circle Z, that's a tangent line, that's a tangent line, and it says find the value of x. So if you understand the idea that I just said on the last slide, this distance is the same as this distance, always. If they're both tangent, they're the same length. So if those are the same length, I need to set them equal to each other. Set them equal. So here we go. 3x plus 2 is going to equal 4x minus 3 because they're the same size. Okay, so I solve this. Maybe I subtract the 3x first, get the x's together. So that will leave 2 on this side. 4 minus 3x is 1x minus 3. Get that x by itself by just adding the 3 over. So that leaves 5 equals x, or x equals 5. There we go. Okay, so these questions here I think are a little easier. Just understanding that idea, the distance from there to there is the same as that distance there to there. So they're always going to set them equal. Just make set them equal. Okay, next one, very similar question. This is what I would have you try to do on your own if you could. Same idea, if they're the same length, just try to solve it down. Okay, so I will do this one on the board, so if you want to try to do it at home, you can try to figure it out. I'll show you what the answer should be. So if you solve that down, you should get 7 for that question there. Okay, since they're both tangent, coming from the same point, then they're going to be the same length. Okay, so those are hopefully not too bad on those questions. Pretty simple. Okay, now the last type of picture we're going to see is a picture kind of like this. So what we have is we have this triangle on the outside of the circle. And a word that we haven't used much yet this chapter is circumscribed. So this triangle QRS is circumscribed around the circle. Which means all 3 sides of this triangle are tangent to the circle. All sides are tangent to the circle. So that's why it's in this lesson. All the sides are tangent. So we're going to be using the same ideas that we just used on really the last question we just did, the one before that. So it says in this picture we got this round cookie and we got a triangular package around it. What it wants to know is what is the perimeter of our triangle QRS, of the full triangle. And remember what perimeter means. Perimeter is the distance around the outside. So what we want to do is add the sides together. Add everything on the outside of that triangle, all the outsides together. Okay, so looking at it, the way we figure this stuff out is you kind of have to break it into 3 different questions. So I look over here at point S first. From point S, S to M and S to N, those are both tangent lines coming from the same point. So if they come from the same point, that means those 2 lengths have to be the same. So if they're telling me that's 10 centimeters, then I know that's 10 centimeters too. That's the idea on these questions. Because say I'm over here to Q. This 2 is kind of hard to tell where it's going to. It's supposed to be going to, I'm not sure which one, I think probably this one, QN. But same idea. If Q to N is tangent, and Q to L is tangent, these 2 lengths are the same too. I'll put 2 dashes on those. So that means this is 2 centimeters. Also get rid of this 2, it's kind of in a weird spot. If that's 2 centimeters, that's 2 centimeters also. Okay, so now if I come down to R, R is a little bit different, but you guys can figure it out. If 8 is this whole length here, and this is 2, how long is this going to be? You subtract it, right? 8 minus 2 tells me that's 6. So then same idea. If R to L is tangent, and R to M is tangent, I'll put like 3 dashes on here to show you those 2 are the same. That's going to make that 6 also. So then the perimeter is going to be add all the little pieces together, and we have our final answer. So I got 10 plus 10, plus 2 plus 2, plus 6 plus 6. That's my perimeter. Don't add this 8 in, because we've already taken care of it with the 2 and with the 6. So don't put that 8 in your little add up in there also. So we got 10 plus 10 is 20, 22, 24, 30, 36 centimeters. So I'll just put a P equals 36 centimeters. Okay, so just to understand that idea, if they come from the same point, then those lengths are going to be the same size. And you just add them together. Perimeter is add them all together. One more of these and that's it. Okay, so I'll go ahead and do it for you. I know I wouldn't have you try to do it on your own if we were all here together, but just make sure we're all good on the same page here. I'm looking at my question. It might be different wording up there, but it's the same idea. Every line is tangent. So from A to E and A to F, they're the same length. So that makes that also 12. Those two are the same. Now over here, CE 6. So CD is 6. Then they did the same thing for us. If the whole thing's 16, and I have 6 there, 16 minus 6 tells me that's 10. And then that means if this is 10 here, B to D, then B to F is also 10. And the final step's going to be just add them all together. Add 12, 12, 6, 6, 10, 10. Don't add in the 16 anymore. It's not part of it anymore. And you got your answer. So 10 plus 10 is 20, 32, 44, 50, and 56 would be our final answer there. So 56 centimeters, the whole perimeter around that triangle. Okay, so that's a lesson. That's lesson 9.5. This is what I have for you. On Google Classroom, this is where you would have found this video at. Along with that video, there should be a 9.5 Study Guide Intervention worksheet attached along with it. So you'll just need to open up a Google Doc. I've got the instructions for you on there. But put all your answers on a Google Doc, submit those answers, and you'll be good to go for this lesson. There'll be an IXL for the next day, which I believe is what, Wednesday? I can't remember right now. But for the next day, I have an IXL that goes along with it. Just open this video up again if you need to and look at the examples, and hopefully you guys can get through the IXL just like you did the worksheet. Okay? Thanks for watching. I'll see you guys very soon in lesson 9.6.